everyone. Today we're doing Notes 2-1, Solve Absolute Value Equations. So the absolute value of a real number x, written absolute value of x, is its distance from 0. So for example, if I ask you to find the absolute value of 4, that means I want to know what is the distance from 4 to 0 on the number line. And if we count, we would go 1, 2, 3, 4 units. So the answer would be 4. The distance from 4 to 0 on the number line is 4 units. Similarly, the absolute value of -4 means I want to know the distance from -4 to 0 on the number line. So that answer would be 1, 2, 3, 4 units. So you can see, since absolute value is distance, our answers here when we compute an absolute value is going to be a positive value because distance is positive. Okay, so let's get to some examples. All right, so solve each equation and check for extraneous solutions or extra solutions. So what's an extraneous solution, you might ask? So hopefully you remember back from the very beginning of the school year, whenever we solved equations and whenever we did that video over solving equations, how I checked some solutions. So remember, when you check a solution, you want the statement that's left whenever you're checking to be a true statement. Well, today, whenever we check some of our solutions, we will have a situation where the statement is not a true statement, and it's not because we made an error. It's because these are extraneous solutions that they seem like they're going to work out, but when we plug them in, they don't officially work out. So, and I'm going to get more into it and show you kind of the graphical aspects so you understand it a little bit better as we go. So let's look at number 1. So the absolute value of x equals 5. How do I solve this? How do I get x by itself? Okay, well, think about this mentally. Okay, so mentally I know input-wise here, what inputs can I have that will produce an output of 5? Well, think about what absolute value means. Absolute value means distance from 0. So what inputs can I put in here that have a distance from 0 of 5? Well, that's pretty easy mentally. Mentally, I know that both -5 and +5 have a distance from 0 of 5 units. Okay, so that means my answer is going to be x could equal -5 or x could equal +5 because both -5 and +5 have a distance from 0 of 5 units. Okay, and if you don't believe me, let's check. Okay, let's check. Let's check our work. So let's first check -5. So this is how we're going to write this. We're going to first check -5. So how do we check it? Remember that we take the solution and we plug it in where we see x into the original equation. So we're plugging in here. So is the absolute value of -5 equal to 5? Is that a true statement? And the answer is yes, because the absolute value of -5 is 5. So that is in fact a true statement. So that's not an extraneous solution, it's a true solution. So then let's check +5. So if I plug +5 in here for x, is the absolute value of 5 equal to 5? And remember, question mark, we don't know. And the answer is yes, the absolute value of 5 is 5. That's a true statement. So actually both of these are true solutions, not extraneous. Okay, so what's really interesting about all this is if I were to graph this equation, and what I mean is think about this is a graph on the left and this is a graph on the right. How would that look? Okay, so I've done it here for you. So if this were y equals absolute value of x, that would be this graph here. And if I graphed the graph y equals 5, okay, that would be a horizontal line that cuts through the y-axis at 5. That would be this graph here. And what if I look at the intersection of those two graphs? Then I would notice that the x values here and here, the x values here is -1, 2, 3, 4, 5. And the x value here at this intersection point is +1, 2, 3, 4, 5. So that's very interesting. We'll come back to that. Okay, so steps for solving absolute value equations. So the first step is going to be isolate the absolute value bars. That means get the absolute value bars by themselves, okay? There shouldn't be anything in front or anything behind. Inside is okay, but nothing in front, nothing behind, okay? remove the absolute value bars by setting up two equations. That's exactly what I did here. All right, the absolute value bars went away. X was by itself. It came out of the absolute value bars. And I set up two equations, one where what was inside equaled a negative value, this value, and one where what was inside equaled a positive value, this value. Okay. Then you solve each equation, then check for extraneous solutions. So let's go ahead and get to it on number 2. So on number 2, our absolute value bars are isolated already. Okay, so we're going to then remove absolute value bars by setting up two equations. So remember, like I said before, what's inside the bars will always stay the same. So the x plus 1 is unchanged. It is unchanged. But here we're going to make this 3 negative 3. And then on the other equation, we're going to make that 3 a positive 3. So remember again, what's inside the bars stays the same. Then on this equation, we have a negative 3. On this equation, we have a positive 3. And then we're going to solve each equation. So I'm going to move this plus 1 across the equal sign in both equations. So here I'm going to have x equals negative 3 minus 1. Here I'm going to have x equals 3 minus 1. So this is going to be x equals negative 4, and this is going to be x equals 2. And now I have to check to see if either of these two solutions are extraneous. Okay, so let's go ahead and check. So first we're going to check negative 4. So plug negative 4 in here where I see x. So absolute value of negative 4 plus 1, does it equal 3? Question mark. Okay, remember when you're checking, you can't move anything across the equal sign. I just need to go ahead and figure out what this value is. So absolute value of negative 3, does it equal 3? Okay, when I combine negative 4 and 1, we get negative 3. And the answer is yes. The absolute value of negative 3 is 3, and 3 does in fact equal 3. I hope you agree with me. Okay, now let's check 2, our solution of 2. So plug 2 in where we see x into the original equation. Is that a true statement? Okay, so 2 plus 1 is 3. So is the absolute value of 3 3? Yes, it sure is. The absolute value of 3 is 3. So therefore, both of these are true solutions. Neither is an extraneous solution. So, and what's really interesting is, let's come over here and look at the graph like we did up above. So if we were to graph y equals the absolute value of x plus 1, that's the absolute value parent function shifted left 1, correct? So that's this graph here. We've shifted the absolute value parent function left 1, and then we were to graph y equals 3, so that's the horizontal line that cuts through the y-axis at 3. And then if I look at those intersection points, I notice that the x value of this intersection point is negative 1, 2, 3, 4. And the x value of this intersection point is 1, 2. So how neato is that? Another thing that I want to point out to you that's really neato is if I plot these two solutions on a number line, negative 4 and positive 2, let's see if we can find some interesting things out. So first of all, between the two solutions, I want to find the middle. Okay, so if this is 1, 2, 3, 4, 5, 6 units, then the middle would be 3 units. So notice, from here to the middle is 3 units. Okay, I'm trying to do my best little brace here. 3 units. So that's interesting because that's this value here, 3 units. Okay, and then the middle number is negative 1. How interesting that it's the opposite number of that. I wonder if that's true for every single problem. So we could come up here and see at least that from the middle to the solutions, that distance was 5 units. So how interesting that that matched the end number like it does here. And then here the middle was at 0 and there was nothing inside here with that x. So let's see if we can see if that holds true on number 3 here. So on number 3, again, we have absolute value bars isolated. So we're going to remove the bars by setting up two equations, one negative equation and one positive equation. And what I mean by that is the value out here, the constant value out here, negative in this equation, positive in this equation, always what's inside here stays the same. Always, always, always. Okay, so then I'm going to move over this minus 4 in both equations to solve for x. So x equals negative 1 plus 4. And here on this one, x equals 1 plus 4. So x equals 3. x equals 5. Let's see if we have any extraneous solutions. So first I'm going to check 3. So plug 3 in here for x. 3 minus 4, does it equal 1? So the absolute value of 3 minus 4. 3 minus 4 is negative 1. Is that a true statement? Is the absolute value of negative 1 1? Yes, it sure is, so we're good there, check. And then let's check 5. So plug 5 in here, so the absolute value of 5 minus 4 equals 1. So 5 minus 4 is 1, and the absolute value of 1 is certainly 1. So again, that's another true statement. So both of these solutions are good. Neither is extraneous. All right, and let's check out the graphs. So again, if I were to graph y equals the absolute value of x minus 4, that would be the absolute value parent function shifted right 1, 2, 3, 4 units like I did here. And then if I were to graph y equals 1, that's the horizontal line cutting through the y-axis at 1. Look at the intersection points, okay, and specifically look at their x values. So the x value here at this intersection point is 1, 2, 3. The intersection point, the x value at this intersection point here is positive 5. So how neato is that again? And again, let's plot these on the number line. Okay, so 3 is one solution and 5 is another. Find the middle. That's easy, right? It's 4. How interesting that once again, okay, the middle here was negative 1. That was positive 1 inside. The middle here is positive 4. Inside here we have a negative 4. And again, our distance from the middle to one of the endpoints, either of the endpoints, was 1 in both cases. So that number there. And I really need you to understand this because in your assignment, you're going to have situations where you're given a number line and you're asked to go backwards and write the equation. And you do that by finding the middle, of course. Okay, you're given the two solutions, you plot them on a number line, you find the middle. And then the distance from the middle to the endpoints tells you this number out here. And then the opposite sign for this guy right here in the middle tells you what goes in there. So it's pretty easy as long as you're listening to the video. Now, if you're just copying the notes, poor you, right? Okay, so number 4. Number 4 is actually the last one we're going to do today. We're going to save number 5 for next time. So on number 4, oh, we get lucky again. Our absolute value bars are isolated, so we can go ahead and split this up into two equations. So the first equation says x plus 2 equals negative 3. Remember, one negative equation and one positive equation. X plus 2 equals positive 3. Okay, so remember what's inside stays the same. Negative here, positive here. Okay, and then on both situations, we're going to move the plus 2 over. All right, so x equals negative 3 minus 2, and x equals 3 minus 2. So x equals negative 5 here, x equals 1 here. So let's see if both of these are true solutions. I'm kind of starting to wonder, based on this graph here, what's going on. Let's check. So check negative 5. Okay, plug negative 5 in here for x. So absolute value of negative 5 plus 2. Does that equal negative 3? Okay, the absolute value, so this is going to be negative 3 in here. Does it equal negative 3? And I should have my question mark. Okay, unfortunately, when I'm working down on the left, the absolute value of negative 3 is 3. Okay, and 3 does not equal negative 3. That's not a true statement. That means this is an extraneous solution. I'm just going to put EXT. Okay, that's an extraneous solution. It looked like it was going to be an answer, but it didn't hold true. It didn't work out. So EXT for extraneous. Let's check the other one. I'm leery since I don't have any intersections. All right, so let's check 1. So this would be absolute value of 1 plus 2 equals negative 3. So that would be absolute value of 3, question mark. Does that equal negative 3? No, because the absolute value of 3 is 3. And that does not equal negative 3. So again, 1 is an extraneous solution. So I put EXT next to it. I still box it up, and I still want to see your answers, even though they're extraneous. But technically, this is called a no solution situation because neither of those solutions worked out. But I don't want you to put no solution. I want you to put what you got and that they were both extraneous. Now, this makes perfect sense because if I think of these graphs, The absolute value parent function shifted left 2, okay? And then y equals -3. These graphs don't intersect each other, therefore we have no solutions. Okay, what's really interesting, if you were to reflect this graph, I wonder if then those two graphs would intersect and where exactly they would intersect. Food for thought, huh? So we've learned a lot today. I hope you had a great time. Can't wait to finish it up with you next time.